Hello everybody, this is a recorded demo of the Arduino based time system just in case the live demo does not end up working out. So as you can see, we have a video capture of the setup on my desk, and I have a screen recording of both of the modules and their syncs. Now I'm going to go ahead and reset both of these Arduinos just so that you can see what everything looks like from the very beginning. So I'm going to go ahead and reset the transmission and reset the receiving. Now, the transmitting Arduino is on the left, the receiving Arduino is on the right. First, we can see that it says that it has achieved its initial sync, and it's waiting for a full atomic sync. What this means is that the WWV AM module has gotten one marker bit. When it gets one marker bit, that means that we can usually assume it's working. Now, the GPS has started, and so has the LoRa module. We can see this as it says that GPS is some weird wonky date. This is because the data is a little weird, and we can see it just corrected itself like that. Sometimes it takes a second, but most of the time it's pretty accurate. You can also see that it's getting the correct time data, saying that it's 5:41 p.m. Something worth mentioning is that we get GPS, the GPS time data, in UTC. So to change it over to MST or NDT, we have to make the correct changes to do so. Now, as you can see, the receiving Arduino just got its sync. Now it is receiving its data, and now we also have a WWV-BAM sync. And you can see that on the left, on the TX, it shows exactly what data it's getting. On the right, it shows this data as well as a WWV-BAM and GPS time difference. In this case, the GPS is greater by 1 second. This will change depending on what values it gets, and we can even confirm this by looking at the two timestamps for GPS and WWV-BAM, and we can see that GPS is in fact 1 second faster right now. We will see if that changes. Hopefully it does, but you can use that to monitor how accurate everything is being. And we are going to continue with our sync. Now, this code, which is not going to be the production code, I've altered it. I've altered it in that this, to show the BPSK module will sync within 2 minutes of there not being a full WWV-BAM sync. So as soon as we don't get a full WWV-BAM sync for 2 minutes, then the WWV-BPSK module will come in and it'll start syncing. In that case, we will see what that looks like, but we just gotta kind of play the waiting game until that happens. And again, GPS comes in as UTC, and so does the BPSK. So we have to perform the same calculations to change it from UTC to MST. This is done on the master Arduino, and then it is just sent to the slave Arduino, the receiving Arduino. Now, as you can see, the WWV-BAM and GPS time difference has dropped to 0. That means they are exactly on the mark, which is good stuff. This is what we like to see. And again, we're just kind of waiting to see, has it been 2 minutes? Now, also what's worth mentioning is, as we know, the WWV-BAM time code does not come every second, right? Or there's one bit that comes every second, but the whole thing doesn't come every second. So although the seconds are ticking on the left and on the right on the WWV-BAM, it is not receiving a signal every second, exactly updating what the time is. How we do this, how we make it tick every second, is when a sync is received, then we set the Arduino's internal clock. On only the transmitting Arduino, only on the TX Arduino, we set its internal clock to that time, and thus it ticks, and we just display that time as it ticks. Okay, I think what I'm going to go ahead and do, because I want to, oh, there we go. Okay, so it's been 2 minutes. As we see, it says, enabling ES100, all functions stopped until sync has been finished. So on the left, it is showing that it is syncing with the BPSK module. On the right, it shows that it's not receiving data. It says likely due to BPSK sync process, waiting for next transmission. It is possible that we aren't receiving data due to a reason other than that of a BPSK sync process, but most likely this is what happens. Now, as mentioned in the presentation, the BPSK will stop every single process on the Arduino. That means nothing will happen while it's getting in sync. The reason why is because it requires a while loop to sync, and this while loop essentially just keeps the code in one spot, does not let it move. So we are waiting for that sync to happen. This sync usually can take anywhere from as fast as 1 minute to as slow as 6. The reason why on the production code it'll take at least 30 seconds between BPSK syncs and 30 seconds after a full or between WWVB AM syncs. The reason why it takes that long in between to sync the BPSK module is because the BPSK module just takes so long and it shuts everything down. And so we want to make sure that we have all those redundancies in place, so there's no reason to just be syncing it over and over again if we're not transmitting the time, which is one of the main goals, is not only for it to be accurate, but for also it to be able to transmit time. So that's what we're doing right here. We are waiting until we get this sync. Okay, and as you can see, we have received a time sync. Now, on the left, it says our UTC, so we are not going to see what we get there. Now, again, we haven't had enough time for the BPSK to sync fully, so I'm going to go ahead and stop our right-hand Arduino just to show you exactly what the BPSK looks like. As you can see, we have the correct time right here. You can check based on my clock as well. And we have the correct date. So that's the BPSK signal. Now, just like with the WWVBAM, we don't get a BPSK sync every second. So on the receiving Arduino, we set the internal clock to the BPSK time so that we can keep ticking. Now again, this would keep ticking normally. In this case, it's not, solely because we have to wait for the next transmission, because this BPSK sync cycle is on a very short interval. It only takes 10 seconds between syncs for it to start again. This is only for the demo though. But that is all for the demo. That shows all of the functionality. Thank you for watching.